the degree of each polynomial. What's the degree of this polynomial? 2, right? X times x is x squared. What's the degree of this polynomial? 3, because x times x would be x to the third. What's the degree of this polynomial? 4. If you multiply all those first terms together, you would get x to the fourth, and that would be a fourth degree polynomial. Notice the graphs are consistent with what we talked about yesterday. If, this is an even one, this is an odd, this is even. Just the shape of the graphs makes sense, okay? Number of x-intercepts. How many x-intercepts in this one? How many x-intercepts in this one? How many x-intercepts in this one? What does that tell you? The degree of the function matches the x-intercepts. That's how many answers you're going to get. Whatever the degree is, that's how many answers you're going to get. Now, relative maxima and relative minima are long, lots of syllables that don't make any sense to us, that just stand for turning point. How many turning points are there? Okay? So like this is a relative minima that has one turning point. How many turning points does this one have? 2. And just to get an idea of the relative minima and relative maxima, what they're really saying is this is the top part of that part of the graph. It's not the top of the whole graph. The whole graph goes up through the roof. But here is a relative maxima right there. So it's just a turning point. How many turning points do we have here? And what does this tell you? The turning points are one less than the degree. If you have a fifth degree polynomial, you'll have 4 turns. Right? That's how many turns you're going to get in your graph. So that's the basic idea there. Now we move on to the next one. What's the degree of this polynomial? This one? This one? Now how many x-intercepts are there here? 0. It does not cross the x-axis. That would have no answer. So remember we did those quadratics, sometimes we got no answer, if we had negative under the radical and all that stuff. That's what's happening here. So you might get 2 answers, you might get 0, you might get 1. You might just touch it and bounce back up. How many intercepts do we have here? 1. 1 x-intercept right there. So last time, it could be 3, or it could be 1, or it could be 2. But it can't be more than 3. And it can't be 0 either, can it? Because a cubic always goes from negative infinity to positive infinity. It has to cross at least once. How many intercepts do we have here? 2. So again, it could be 4, but it could be less than 4. And that could be 0 also. And so that's the basic idea of just the basic concept of how many answers you're going to get when you do one of these questions. Okay, there's some good vocabulary there, some good reading for you tonight before you go to bed tonight. Go through, make sure you understand all these words. So as I use them, we're talking the same language. I don't like question number 1, so we'll skip that if that's okay with you. Find the zeros for me in question number 2, please. How are we doing on time, Rachel? To go or gone? In. Okay. Thanks. So we're going soccer style. We're counting up. Okay. No. No. Honest. I got 3 zeros. I got -2, +4, and +6. And you asked a very good question. Should we distribute the negative? Normally you would say yes, wouldn't you? But this is factored form. We've already factored it. And if you did distribute it, you'd have -x - 2. You would still end up with the same 0. It'd just be a long way of getting there. So we're not going to distribute the negative. So we know what our zeros are. Our zeros are -2, 4, and 6. So let's sketch our axes here. Put in our zeros. And those 3 boundary points separated our graph into 4 sections. And the first section would be where x is less than -2. Our next one is between -2 and 4. Our next one is between 4 and 6. And then our last one is what happens to the graph greater than 6. So I want to know what's going on in the graph before this point, between these 2 points, between these 2 points, and then the end behavior at the end of the graph. So let's pick a number less than -2. Did I hear -4? Now this negative is still here, right? So at -4, you would have that negative. Then you'd have -4 plus 2, which is -2. Then you'd have -4 minus 4, which is -8. And then you'd have -4 minus 6, which is -10. So you would have a negative times a negative times a negative times a negative, which would be positive, because there's 4 of them. So this graph is positive over here. Now we pick a number between -2 and 4. I'm going to pick it for you because I like 0 so much. 0 falls into that range, so I'm going to use 0. Again, this negative is always here. Then I have 0 plus 2. That's a positive answer. 0 minus 4, which is a negative answer. And a 0 minus 6, which is a negative answer. And I have a negative times a positive times a negative times a negative. There's 3 negatives. So the answer would be negative. And what would the y-intercept be? It would be negative times 2 times -4 times -6. I think of that as a -1. -48, I think it is. It doesn't really matter. It just makes it's consistent with what I'm saying. We're saying it's going to be negative down there. We get a negative y-intercept. Everything should be making sense. Pick a number between 4 and 6. 5. We still have that first negative. And then we have 5 plus 2. We have 5 minus 4. And we have 5 minus 6. So we have a negative, positive, positive, negative. That would be positive. These values from here to here are positive. And then you pick a number greater than 6. Let's say 10. You would still have that negative. You'd have 10 plus 2, 10 minus 4, and 10 minus 6. 1 negative means the graph's going to go that way. I'm going to be completely honest with you. I don't ever do that. All right, I'm just showing that now because I have to. I know what the graph looks like, and that's what I tried to show you yesterday. I know it's a negative cubic. Starts at positive infinity, goes to negative infinity. I know it goes through those points, so it's going to alternate all the time, isn't it? Positive, negative, positive, negative, positive, negative. When does it bounce off the point? If there were 2 of them, right? If you can remember that, you don't ever have to do that. Okay? You can understand the concept, and you're going to see a problem coming up where you need to understand the concept, but you don't have to do it. Unless you like it. Okay, so let's go to number 3. You should be able to graph that without using your graphing calculator. Don't do what I've been showing you today. Don't do all that math unless you like it. Find the zeros and sketch the graph because you know what this graph is going to look like. What degree polynomial is it? 3. And you know what a 3rd degree polynomial looks like. Mm-hmm. So by now you realize you have to factor this expression, don't you? Factor by grouping. There's 4 terms there. Help your partner out. I'm seeing partners where one person knows what's going on and the other one doesn't. It's a lack of communication. X squared minus 1 factors again. You're the best. Hi, Mrs. Herrick. Say it louder. Yes? Does everyone know Mrs. Herrick? What'd you give me? Oh, that's because, yeah. No, well, it was one of those jobs that didn't print, so I don't need it. And then it printed. You know what I mean? It's not your fault.
I just saw a staff, so I grabbed it and wrote it down.
Hey, I appreciate that. This is fun stuff. You like this stuff? This guy knows what he's doing.
Yeah, and they come to me and tell or freak out, and they're just amazing with it. Especially the factor.
Is Ashley factoring correctly?
Oh, I think you can go further. All right.
How many zeros are there going to be? So when I factor this, I got x squared minus 1 times x minus 2. Now you know there's 3, so it's kind of a hint to tell you this is going to factor again, x plus 1, x minus 1, and then x minus 2. And your zeros are going to be negative 1, positive 1, and positive 2. So you sketch your x and your y axes, you put in your zeros. Negative 1, positive 1, positive 2. You know it's a third degree. You know what your third degree looks like, don't you? If not, you can do all your tests. What's the y-intercept? 2. That's that number right there. So we do know it's going to hit there also. So I know it's going to go boom, boom, boom. Out go the lights. Are we good? Okay. Did you move on to number 4? You can always work ahead. You can always move ahead when you're sailing away. This one does not factor. But they give us enough information to graph it anyway. Negative 1, 1, and 3 are zeros. And this one says we just have to do it by determining the sign of the values between those functions. So we got to get the sign over here, between there and there, between there and there, and over here, right? So you pick a number. Pick a number less than negative 1. Pick a number between negative 1 and positive 1. Pick a number between 1 and 3. And pick a number greater than 3. All right, so work together. Pick one number. Work together. Tell somebody else what number to pick. You pick a number. Tell the person behind you to pick a number. You should only do one. Between 14 of us, we should be able to get all 4 numbers in real quick. Okay, talk to me. Who picked a number and what'd you get? You picked less than negative 1? So you got a negative? You picked 0? And what'd you get? So you picked 2. You picked this 2 up here.
Yeah.
Are you a positive? Are you positive? Did anyone else pick in? What'd you get?
Like,
What did you pick? Whatever you picked. What number did you pick?
Yeah.
You picked 0. Did you get a positive or negative answer? I think it's negative. I don't know for sure. Check. This one's positive.
Yeah, I have.
Did anyone do
Mine
that?
negative. Mine negative.
For which
Mine
one?
Negative, negative. That's like-
So you're plugging your values in here, right? What's that? Okay, this is scary. So let's get it right. All right, let's use the calculator and get it right. Let's go to y equals and put this function at x to the 4th minus 4x to the 3rd plus 2x squared plus 4x minus 3. And let's use our table. All right, obviously we could just graph it to see what it looks like at this point. So let's use the table because I want to get this right. So go to the table, and what do you have at -1 or -2? So pick a number less than -1. Less than -1. So that's positive? Is that what we had before? Now look at 0.
Positive or no negative?
0 is negative. And now I knew that, all right, because if x is 0, none of these things matter. It's going to be -3 if x is 0. How about 2? What do you have at 2?
Negative.
A negative?
I have a positive.
We have a positive?
It says minus is -3. Yeah. Mine says 13.
Okay, now this is really getting scary. Go to y equals. And let's see if we did that right. X to the 4th minus 4x to the 3rd plus 2x squared plus 4x. Keep going.
Yeah, I got it. It should bounce at.
So this is negative here now?
Yes.
All right, so who had positive? Let me look at. You found a mistake? Okay. So is it negative there then? And then what about greater than 3? That was positive? Do we agree now? Okay. So our graph would be positive, negative, and we know it's going to hit at -3. And then we got negative again, didn't we? And then positive. Now that does make sense to me, okay? Because it's a 4th degree, it should have that basic form where, like the parabola, goes to infinity, positive and negative at the end, right? The end behavior, okay? Now obviously if we have a graphing calculator, all we have to do is plug it in and graph it and see. But this concept I need you to understand. So, one last question, right here. And I'm not going to go over it today because I don't want to rush through it. I want you to understand it. So you don't have homework, but your homework is this question. So do as much as you can now. Maybe you'll finish it. Just get this question done. Remind me tomorrow I didn't finish today's lesson and I need to start here. Because I really wanted to get this done today, but we got caught up on positives and negatives a little bit.